Welcome to this session. So we discuss the solutions to the Cat 1 that was done on 13 January 2022. The first question, 1 part A, was asking us to show whether the function f of x, y, z given by square root of x squared plus y squared plus z squared satisfies this Laplace equation. So to prove this, or to show whether the equation is satisfied or not, we have to get the partial derivatives of the function with respect to x, partial derivative of the function, second partial derivative of the function with respect to y, and second partial derivative of the function with respect to z, and then get the sum of those partial derivatives and check whether the solution will be 0 or not. So solution. So partial f, partial x. Now, one thing that you have to remember is that this function can be written as x squared plus y squared plus z squared raised power a half. So that's the interpretation of square root function. So by chain rule, we'll drop this half, and then we have x squared plus y squared plus z squared, and then subtracting 1 from this power, we get negative a half, and then you differentiate partially inside with respect to x, and that will give you 2x. So once you do that, half times these 2 gives us 1. So the function will be partial f, partial x is given by x into x squared plus y squared plus z squared raised power negative a half. So that's the first partial derivative of the function with respect to x. Now the second partial derivative of the function with respect to x. Now we differentiate this first derivative. Now, because this is a product of two functions, we can let this one to be u, this one to be v. So by product rule, we'll have u prime v plus v prime u. So u prime, when you differentiate partially this x with respect to x, you get 1. So 1 times x squared plus y squared plus z squared raised power negative a half, and then plus v prime. So differentiating this one by chain rule, will have negative a half. So you drop this power, and then you have x squared plus y squared plus z squared, and then subtract 1 from this power, you get minus 3 over 2. And then you differentiate partially what is in the bracket with respect to x, you get 2x. And then you multiply by u, which is x. So when you do that, we get partial squared f partial x squared will be given by x squared plus y squared plus z squared raised power negative a half. And then, so this negative times plus will be negative, and then you'll have these 2 cancels with these 2. So we'll have x squared into x squared plus y squared plus z squared raised power minus 3 over 2. Now you see these 2 terms, we can factor out x squared plus y squared plus z squared raised power negative 3 over 2. And then you need to multiply this term by x squared plus, you need to multiply this by x squared plus y squared plus z squared raised power 1. So that when you multiply this term by this term, you get this bracket raised power negative a half. Negative 3 over 2 plus 1 is negative a half. And then minus this one will have x squared. When you simplify this, So partial squared f partial x squared will be given by this. And then raising to power 1 is just like writing without brackets here. So this means partial squared f partial x squared is the same as x squared plus y squared plus z squared raised power negative 3/2 into, now here x squared minus x squared will give me 0. So I have just y squared and then plus z squared. So let me call this one equation 1. Then similarly, when you work out the second partial derivative of the function with respect to y, it will take the same structure. So similarly, you should confirm that partial squared f partial y squared will be x squared plus y squared plus z squared raised power negative 3/2. But then I will have x squared plus z squared. So you can call this one equation 2. And then partial squared f partial y squared, partial z squared will be given by x squared plus y squared plus z squared raised power minus 3/2. And then we'll have x squared plus y squared. So we call this one equation 3. Now, the required equation is simply taking equation 1 plus equation 2 plus equation 3. So adding 1, 2, and 3, we get partial squared f partial x squared plus partial squared f partial y squared plus partial squared f partial z squared will be given by, now one common thing that you see on these three equations is that x squared plus y squared plus z squared is power minus 3/2 is common. So I factor it out. X squared plus y squared plus z squared raised power minus 3/2 into, now the first bracket here in the first equation is y squared plus z squared. So I write y squared plus z squared plus, in the second equation we have x squared plus z squared in the third equation we have x squared plus y squared. So this is what I get. Now in this square bracket you see each of these squares are 2 of them. So I'll have, that will give me x squared plus y squared plus z squared raised power negative 3/2 into, so I'll have 2x squared plus 2y squared plus 2z squared as the answer in the square bracket. So the common thing is 2 can be factored out. So 2 into x squared plus y squared plus z squared raised power minus 3/2. And then this will be x squared plus y squared plus z squared. I can say power 1. And using laws of indices, this bracket and this bracket are the same. So I can add the powers. Negative 3/2 plus 1 is negative 1/2. So I'll get this one to be 2x squared plus y squared plus z squared raised power negative 1/2. So clearly, which can as well be written as 2 over the square root of x squared plus y squared plus z squared, which is not equals to 0. Hence f of x, y, z equals to square root of x squared plus y squared plus z squared does not satisfy the Laplace equation. Partial squared f, partial x squared, partial s squared f, partial y squared, plus partial squared f, partial z squared equals to 0. But note that if you are given, confirm this, note that if you have a function u, x, y, z given by 1 over square root of x squared plus y squared plus z squared satisfies the Laplace equation partial squared u partial x squared plus partial squared u partial y squared plus partial squared u partial z squared equals to 0. Let's quickly show how this one works. So u is same as x squared plus y squared plus z squared raised power negative a half. So remember, when you write square root the same as raised power half, so when you take it to the numerator, then it will be having negative power. So partial u partial x will be given by, so drop the power, so negative a half x squared plus y squared plus z squared. So subtract 1, you get minus 3 over 2, and then differentiate partially inside the bracket, you get 2x. So this will give you negative x into x squared plus y squared plus z squared raised power minus 3 over 2. Now with that, second derivative of u with respect to x will be given by, you use product rule. So let this one to be u, let this one to be v. So we have u prime v plus v prime u. So negative x is what I'm calling my u, and the rest is what I'm calling the v. So u prime is -1, so it'll be negative into, or say -1 into x squared plus y squared plus z squared raised power minus 3 over 2 plus, now v prime, this one I'll drop -3 over 2, and then I have x squared plus y squared plus z squared, and then subtract 1 from this power, you get minus 5 over 2, and then differentiate inside, you get 2x, differentiate inside partial with respect to x, and then you multiply by u, which is minus x. So you see these 2 and 2 cancels out, and negative cancels out. So we'll have -1. So partial squared u, partial x squared will be -1 into x squared plus y squared plus z squared raised power minus 3 over 2. Now because this and this cancels out, so we'll have plus sign. 2 and 2 crosses, so we'll have 3x squared into x squared plus y squared plus z squared raised power minus 5 over 2, which you can simplify to factor out this term. So we'll have partial squared u partial x squared is given by x squared plus y squared plus z squared raised power minus 5 over 2 into, now here you need to have negative x squared plus y squared plus z squared, or say negative 1 into. This you need to raise to power 1, so that 1 plus minus 5 over 2 gives you minus 3 over 2, and then plus 3x squared. You simplify further, and you get partial squared u partial x squared will give you x squared plus y squared plus z squared raised power minus 5 over 2 into, now raising to power 1, so I can just multiply every term by negative 1. So I'll have negative x squared, negative y squared, negative z squared, then plus 3x squared. So simplifying this one further will give you partial squared u partial x squared equals to x squared plus y squared plus z squared raised power minus 5 over 2 into, so this will give us 3x squared minus x squared is 2x squared, and then minus y squared minus z squared. So you call this one equation 1. And similarly, for partial u squared, partial y squared will have the same structure. So similarly, you can always confirm that partial squared u partial y squared will be x squared plus y squared plus z squared raised power minus 5 over 2 into, now 2y squared minus x squared minus z squared. Call this one equation 2. And then equation 3 will be partial squared u partial z squared will be x squared plus y squared plus z squared raised power minus 5 over 2 into 2z squared minus x squared minus y squared. Call this one equation 3. So adding 1, 2, and 3, adding equations 1, 2, and 3, we get partial squared u over partial squared partial x squared, partial squared u partial y squared plus partial squared u partial z squared will be, now you see this bracket raised power negative 5 over 2 is common to all of them, so I factor it out, x squared plus y squared plus z squared raised power minus 5 over 2 into brackets. So the first one I have 2x squared minus y squared minus z squared. So 2x squared minus y squared minus z squared. The second one, I have 2y squared minus x squared minus z squared. And then next one I have 2z squared minus x squared minus y squared. So I'll have this as x squared plus y squared plus z squared raised power minus 5 over 2 into, now you see 2x squared and then minus x squared is minus 2x squared, and then plus 2y squared, and then minus y squared is minus 2y squared, and then plus 2z squared, this one here, minus z squared is minus 2z squared. And it should be seen that this part gives you 0, this part gives you 0, this part gives you 0. So we have the bracket x squared plus y squared plus z squared raised power negative 5 over 2 times 0, which is 0. So therefore, that's the proof for that given second case of the function. Thank you.